All right, so we're going to be doing linear regressions today. So it's section 2.3, part E. You can see that I actually have the worksheet that you're supposed to use to do the homework assignment. But linear regressions has to do with you being able to estimate the values of things that we don't know yet. So for example, I can draw a line that'll estimate certain behavior up to, let's say, 20 years. But that line can be used 40 years in advance and 80 years in advance. Even though I didn't graph that far away, it's called the regression, like what happens as time goes on, right? So they're called prediction equations, or lines of best fit. There's a lot of different names, but that's what we're going to kind of be working on. So I'm going to do a couple of little notes. You can put these notes on the side, like if you want, like see how there's like empty space right here. By the way, where it says go to CudaWorks, don't worry about that. I forgot to delete that, okay? Because we're not using CudaWorks. But you can use any of the white paper to take your notes, or if you want to do it on a separate sheet of paper, feel free, okay? So, a couple little things that you guys have to know, okay? So first off, you guys have to understand correlation, okay? So correlation of a scatter plot. Okay, so correlation of a scatter plot. So in other words, whenever I decide to put a bunch of points on a graph, okay, they might look like they're doing something. Okay, so we call that a correlation. So I'll give you an example. Okay. If I have a graph that kind of looks like this, here we go, here's some dots, okay? All right, do those dots look like they're moving upwards, downwards, or they're kind of staying everywhere? They kind of look like they're trending to go up, even though they're kind of all over the place. But I would say that they kind of are trending upwards, right? They kind of look like they're moving that way. So if the points look like they're trending up, we call it a positive correlation. That means that the information is trending up. So a good example, this would be like gas prices since the year 2005. Okay, slowly they keep rising and rising and rising. So that would be a positive correlation. Okay, so all right. Well, if there's a positive correlation, then it only makes sense that there'd have to be a negative correlation. So a negative correlation means that your data trends downwards, right? So you can see the points are all kind of scattered everywhere, but if you kind of imagine it, it kind of looks like there's a line that's going down through it. Okay, so if it looks like it's going downwards, we call that a negative correlation. Currently, I do have a negative correlation going on in my life. My kids are both in college, so the money in the bank is going down. Okay, different amounts all the time. Okay, so negative correlations, things are trending downwards. Okay, positive correlation, things trend upwards. Okay, by the way, that blue line that I'm drawing, okay, that blue line, that's called the prediction equation or the line of best fit. Okay, so I'm going to kind of write that down. So that line is called let me move it this way here. Prediction equation. Okay, the prediction, actually let me do a highlight there. It's called the prediction equation. Okay, some people will call it the line of best fit or the best fit line. So I'm going to put that in parentheses here, the best fit line. That means that that line represents those points the best. It fits those points the best. It may not even touch any of the points, but it goes through those points the best it can possibly do. Okay? I always imagine it like anybody here. How many of you guys here do not know what Star Wars is? Does everybody kind of know what Star Wars is? Okay. You guys know like when in Star Wars, they decide to go into warp speed, right? But before they can just do warp speed, they need to go to the computer and get it going so it can calculate a safe space through all the asteroids and moons and stars and et cetera, et cetera. That's kind of like the line of best fit. They want to go through all of this mess out in space through a straight line without hitting anything. So that's what that computer is calculating. How can I go from here to here without hitting anything? Because if it's miscalculated, they're going to crash into something and they die. Okay? So a line of best fit, the idea is used in Star Wars. Okay, now granted, they're like, all right, Chewie, let's calculate M and you're calculating B, right? They're not doing that. Okay? But that is what the computer that they punch numbers in is supposed to be doing, finding that line of best fit. All right, or the prediction equation, okay? Why is it called the prediction equation if I just told you the line best fits the point? Because remember how I told you earlier, if I draw a line and it only represents 20 years, I can still use that line for 40 years, 80 years, 100 years. I can predict based on that line that I draw. Okay, so that's why they call it a prediction equation as well. So this is more of a business thing. So those of you guys that are gonna maybe go into business when you guys, if you happen to go to college and stuff and graduate with a business degree, this is a very common practice you guys are gonna see because you guys have to know whether the markets are going up or if they're going down, right? Just look at any business channel and look at the graphs. There's tons of scatter plots everywhere and lines going in between. Those are all lines of best fit, okay? So there is one more correlation. If there's a positive and a negative, does anybody remember what the last one is? It's called none, neutral or none, yeah. But if it has no correlation, because it's scattered in a way that I can't really tell if it's going up or down, right? And I'm not going to draw a line straight because I don't even know if it's going straight. Maybe it's trending up. I have no idea. Something like this will have no correlation. Okay? So it has no trend. I can't tell if it's trending up or if it's trending down. It's just everywhere. Right? It's everywhere. So again, positive, negative, or no correlations. Okay? Because that's going to be one of the questions they're going to ask you on your homework is they say, like, look at your graph. Does it have positive, negative, or no correlations for this one? All right. So, all right. Let's go ahead and go to your computer. And right now we're going to get to the computer portion of it. Let me go to the right worksheet portion. So that's where I want to be, right there. So you're turning... you're turning your paper over to the anthropologist one. It says A on it. Okay, this is the only example we're going to do, but I'm going to kind of go through a lot of steps on it. Okay, but first I got to show you guys how to do this on Desmos. You're going to let your computer do all the work for you. You just got to do all the deciphering. Okay, thank you. You just have to do all the deciphering. Like, what does this mean? What does that mean? So here we go. Let me go to Desmos. So remember, Desmos.com, that's where you want to go, and then on the very front page you're going to want to hit the graphing calculator. I'll go back to it just in case you're wondering where the heck am I. So when you go to Desmos.com, just click on where it says Open Graphing Calculator. Okay? So make sure you guys learn how to do this, because if you don't know how to do this, good luck doing the homework. Okay? And it's not that hard to do. Just follow along. Okay? So if you read the instructions that they give you in the worksheet, let's just read this really quick. It says, anthropologists use a linear model that relates femur length to height. So the length of your femur, so from your knee to your hip right here, is going to relate to your height. So if your femur is a certain length, they can determine that you're so tall, right? Like maybe you're 4 feet based on your femur. Maybe if your femur's longer, they can say, oh, you're like 6'5". Okay, they found a relationship that does that. Okay, they can figure out how tall you are. It says the model allows an anthropologist to determine the height of an individual when only a partial skeleton, including the femur, is found. In this problem, we find the model by analyzing the data on femur length and height for 10 males given in the table. Okay, so part A says make a scatter plot of the data. I don't want you guys to graph this by yourself on a piece of paper. We're going to let Desmos do it, okay? But first, you guys should know this, I'm sure, but whenever you have a T-table, a chart right here, the first column is always X, right? And then the next column is Y. So, don't know, man, my pen fell asleep again today. Give me a second. I was saying, sorry about the pen dying there, but this is normally my X. This is normally your Y, right? Whenever you make a table, X and Y. So remember that. So label it on your paper and then go to the other side and label it X, Y on that chart too. That way you don't forget, oh, where's my X's, where's my Y's. Now, why do I do that? Well, let's go to Desmos. And on Desmos, we are going to put in all this data into Desmos, this big old table. So here we go. So I'm going to click on the little plus sign right here. I don't know if you guys see it, like left corner, almost towards the top. So right up here, I'm going to press the little plus item. And then I'm going to click on the word table. Okay? And when I do that, you see kind of like a little tiny table pops up. You notice how right next to where it says Y sub 1, it's for me it's in green, but it has a bunch of little dots because it knows you're about to do a scatter plot. Okay? It knows you're about to do a scatter plot. So what I'm going to do is I'm going to get the information from my chart and I'm going to put it in here. So let me start with the X's, okay? The very first X that I got is 50.1. The next one, 48.3. I'm just pressing down, okay? After 45.2, and just keep entering, guys. I'm going to do it just like you guys are. 44.7. What's next? 44.5. After that is 42.7, 39.5, and 38.0. So just 38. And then I'm going to go to the other side where the Y's are. Okay? And I'm going to put the 178.5. 173.6, 164.8. This, what do I have? So I have 163.7, 168.3, 165, 155.4. and 155. I hope this will work for me because I don't see the chart here, but let me see. All right, so guys, we do have this table all done, okay? And like I mentioned earlier when I was paused, you don't see anything, but notice my X values are in the 38 to 50s, right? And I'm only going up to 10 right now. My Y values are 155, 178. That means I need to zoom out, okay? So I need to zoom out, and there they are. That's where they're at, okay? So my first question to you guys would be, what kind of correlation does this look like? It looks like positive, right? It looks like positive. It kind of looks like the line is going up. So let me go really quick to this part right here. And I'm just going to ask a quick question. So give me a second. So I'm going to write, what correlation is it? And you guys said positive, so that's good. All right, so that's the first question that you're going to see. Like when you guys do your homework, there's going to be a question like that. It says, what kind of correlation isn't. Okay? Then the next question that they ask you is, what's the slope? And then you're thinking like, I have no idea what the slope is. Okay? Well, there's a cool way to figure that out. So let me show you guys. Okay? So I'm going to go back to Desmos. And I'm going to click right under the graph to open up another little bar. So I clicked like right here. Okay, so if you don't see that box, just go under it like right here and click on it. Okay? And now I want the computer to generate an equation for me. I don't want to do it. I want the computer to do it. So here's how I do it. You see how up there on the table it says x1, y1? So instead of me writing y and m and x plus b, the x and the y have to be ones. They have to be little sub ones. So here's how you do it. You're going to type y1, literally type y1. And it puts that little y sub 1 for you. And then you got to write in the tilde symbol. Tilde is shift and above tab. It's a little squiggly line. Right? And then type in m, x1 plus b. That's all you have to do. Just type it in like that. Okay? And then I hit enter. Notice it drew a line for me. It says this is the line that best fits the information you just gave me. Okay? So now I want to answer some questions. What's the slope? So you see the box under the ymx plus b portion? There's an m, there's a b, then an r squared, r, and e1. Don't worry about the r squared, r, and e1. That's statistical information. What's my slope? 1.9231, right? 1.9231. What's my b value? All right, 80.6809. Those are two questions they're going to ask you on your homework. Okay, I know you don't see them on this sheet, but on the other sheet they're going to ask you that. So let me go back to the written portion. Okay, and what is the slope? We said that is m equal to 1.92. What was it? 231. That's the right slope right there. We're good. All right, and then they're going to ask you, what is the y-intercept? So, what is the y-intercept? So that's B. So B would be, I know it was 80.68, what? 09. All right. Okay, then they say, what's the equation then? Like if you write out the equation, what is it? So, what is the equation? Well, that would be y equals 1.9231x plus 80.6809. Right? That's y equals mx plus b. So was that hard to figure out? I mean, the computer did it all for you, right? We're not too worried about it. But there's that. Now, they're going to ask you a couple other questions. And these are the ones that are kind of like a little bit more where you got to do a little bit of work. So they're going to ask us the following question. So we're doing let me see. What is the femur length for a male that is, and we're going to do a part A and B here, 180 centimeters, and B, we'll do 140 centimeters. Because notice those measurements are not on your chart. Look at the chart. The tallest they went is 178.5. The shortest they went was 155. So again, this is why they call it a prediction equation. Okay? When they ask me for the femur length, what letter are they talking about? X or Y? X, right? They're asking me for X. We labeled that on our little chart, right? That's our X value, right? The femur length is X. So they want me to solve for X, knowing the height. Well, the height is Y. So here we go for part A. Y is 180, so 180 equals 1.9231x plus 80.6809. Now you're going to have to use a calculator. I'm going to use mine right here just to help us out, but you're definitely going to want to use a calculator. So I'm going to get 180. I got to subtract 80.6809, right? So minus 80.6809. So I get 99.3191 equal to 1.9231x. And then my last step is to get rid of that 1.9231. So I got to divide by it. Guys, don't get intimidated by the work. This is the same thing we've been doing. It's just the numbers are decimals. Okay, so don't get scared by it. So x is equal to, well, let me divide here. Divide that by 1.9231. And it comes out to 51.6, let's say. So 51.6 centimeters. So if someone is going to be 180 centimeters, then their femur should be 51.6 centimeters. You know what? We won't do part B because I don't want to waste too much of your time. Let's just do part A. Okay? Because you're going to do one on your own. Then they're going to ask you one other type of question. So I want to do those and then we'll be done. The other question is going to say, if the femur length is this long, then how tall are they? Right? So for this one, I asked you guys, find the femur length if they're this tall. Now they're going to switch it and they're going to say, well, if the femur length is this big, then how tall are they? So here we go. Last problem, and then we're done. So let me put it right here. How tall is the person if the femur found was, I don't know, let's say they don't have a 40 there, right? So the femur lengths go like 39, 42, 44. So let's go with 40 centimeters. So I expect their height to be somewhere between 155.4 and 165, according to the chart. It's going to be somewhere in between there, okay? Because I said a 40 centimeter femur. So notice, I don't have a 40 centimeter femur. It's in between here. So I expect them to be between 155.4 and 165. Okay, that would be my expectation. If they come out to be like 130, I would check my work. Because that doesn't make sense, right? The bigger the femur, the taller they're growing, right? So here we go. So if I know the femur is 40 centimeters, my femur is X or Y? X. So I'm trying to solve for Y then, the height of the person. And that's going to be M, which is 1.9231, times X, which is 40, plus B, which is 80.6809. Remember, I'm just using the formula we wrote. Okay, I'm not making these numbers up. I'm using the formula we wrote earlier. So this one's a little bit easier because I don't have to move anything left to right. Let me just do this calculation here. So I'm going to get 1.9231 times 40. I'm going to hit enter. And then I'm going to add 80.6809. And I get Y equal to 157.6 centimeters. Does that make sense? 157.6. Let's see. 157.6 should be in between 155 and 165. Yeah, that makes sense. Okay. And this is what your homework is. You only have one problem for homework in a sense. You're just doing this question with the cans and the temperature. And then you're going to use this question to, by the way, for those of you guys online, this is what I'm talking about. You're going to use that question. Okay, you're going to do what I did. You're going to create a scatter plot using the table function. You're going to plug everything in. Then you're going to figure out the equation of the line using the equation they wrote right there, y sub 1 squiggly line m x sub 1 plus b, right, the tilde symbol. And then I'm going to give you a piece of paper right now that's going to ask you the questions I just did with you. What kind of correlation is it? What's your slope? What's your y-intercept? Write the equation. Since this is cans and temperature, how hot was it when they sold this many cans? If it was this hot, how many cans did they sell? Right? Like they're going to go back and forth asking you these questions. But it's going to be pretty much what we just did with the femur and height right now. Okay, just a different situation. You guys have any question on the Desmos portion of it? How to write out the information, how to find the information? Any questions on that? Okay. Remember to put the sub ones. You don't have to do anything special. Just press X1 and it'll always write it below. X sub 1. Okay. Y1 will do Y sub 1. All right. And then remember your slope is given to you. Once you write that little weird looking equation, it'll give you the slope. It'll give you the intercept. It even gives you the statistical analysis of it. Okay. But you don't have to worry about the bottom 3 variables. Those are not for us. Okay. And then once you do that, you're going to use that information to help you solve your problem. So let me give that to you guys. Let me end the video and I'll give you your homework.